Okay, welcome to 11.3 corresponding, or lesson 11.3, corresponding parts of similar figures. As usual, I will not be going in depth into the explanation parts of this Explain1 section. I'm going to let you do it. However, one thing that I do want to point out is that I'm going to be referring to these two properties, right? Corresponding angles of similar figures are congruent, so that's our congruency statement, our congruence statement. And then the second one is this idea of corresponding sides of similar figures being proportional. So those two properties are going to play a large part in the explanations as I do these problems. So jumping to the your turn questions here. Here's your turn question number 1 on the next page. Figure ABCD similar to figure MNKL when we are asked to write a proportion that contains BC and KL. So we just have to write a proportion that contains these two segments. I think the first thing we should do actually to help us think about this problem is actually draw the shapes. So if I were to draw just a simple quadrilateral here, A, B, C, D, and a similar figure M, N, K, L, and keep in mind I'm kind of going in the same order, and by order I mean A, B, C, D. I'm going kind of in clockwise order, and same thing with M and K, L, right? So in any case, we need a proportion that contains BC and KL. Let me change the color here. So we're gonna write statements that contain BC and another statement that contains KL. Okay, or segment KL. Okay, so let's write the BC one first, right? Now, like I said earlier, we're going to be referring to the properties of similar figures. And the first one, if you recall here, the second one was that corresponding sides of similar figures are proportional. And so the corresponding side to BC would actually be NK over here. Okay, so the statement we would write is that BC is congruent to NK on the other shape in the same way that CD is congruent to KL. CD is congruent to KL. Okay, and we have to be mindful where we put these segments, right? If we're referring to this as shape 1 and shape 2, right? I want all the shape 1 segments to be in the numerator section of these ratios here, right? BC and CD are both from shape 1, and then NK and KL are both from shape 2. But in any case, here we go. There we have it. We have our proportion that contains both BC and KL. Okay, here's question number 2. DEF is similar to STU, or let's write a proportion that contains ST and SU. So again, I think it helps to draw the shape first. So here's DEF, and we're just going to quickly draw another shape STU. And again, we're naming these vertexes kind of in clockwise order from the same starting position. So we need something that contains ST and SU, okay? So let's go ahead and do that. So we want something that contains this one right here, and SU, this one right here, okay? And let's take a look at where the corresponding sides are on the other shape, right? For example, this ST side would be similar to DE over here, and SU would be similar to DF over there. So the congruent statements that we're going to come up with is that ST is being compared to DE on the other shape, and that's going to be equal to SU being compared to DF on the other shape. Okay, so again, it's because of that second property of similar figures that says corresponding sides of similar figures are proportional. Okay, question number 3. Triangle XYZ is similar to XVW. So let's draw it again. XYZ, XVW. And we are asked to write congruent statements, or the congruent statements that must be true. And that's that's that first property of similar figures that we referred to earlier that said corresponding angles of similar figures are congruent. And so the congruence statement, or there's going to be 3, right? Because each of these triangles have 3 angles, right? So let's do the easiest one here. I'm going to change the color here. X and V, or X and X actually, are going to be equal. So that's our first congruent statement. Angle X is congruent to angle X. Okay. Our second set of corresponding angles are going to be Y and V. So the congruence statement would be angle Y is congruent to angle V. And lastly, Z and W are congruent. So angle Z is congruent to angle W. Okay. All right. So those are the 3 your turn questions. Let's move on to the Explain2 section here. And again, you can read these explanations on your own, but again, we're going to be using the same 2 properties of similar figures, and specifically the one about corresponding sides. Okay, so here's your turn question number 1 for the Explain2 section. We are asked to find the value of X, and we're assuming that ABC is similar to STU. Now, to complicate things, they kind of made it so that these 2 shapes here are kind of, let me see, they're in a different position from each other. Okay, so if I were to, for example, take that shape and then I were to rotate it, right? We can see, right, we can actually see that they are similar figures, right? If I was able to rotate it perfectly, right? But in any case, one of the things that we should be able to catch is that this angle and this angle are the corresponding angles. And so we're going to set up a simple algebraic statement to solve that. So 4x is equal to 100. In order to solve for x, we need to divide by the coefficient of 4, and we end up with x equals 25. Okay. Question number 2, what must be missing? What must be the missing length for the 2 figures to be similar? Well, remember, the corresponding sides have to set up the same proportion. So if we compare this and this, right, if we say 6 compared to 9, right, that should be equal to 12 compared to this. 12 compared to the unknown, which we're just going to label as x. And then we just cross multiply, right? We're going to multiply these 2 and set it equal to this. So here's the equation that gets set up. 6x is equal to 108. Divide by the coefficient of 6. We end up with x equals, what is that, 18? Yeah, 18. All right, question 3. We have this diagram over here that says that triangle AB and ACD are similar. Okay, find the value of x. Well, ABE is the smaller triangle, but the corresponding angles would be this one and this one. That will help us solve for the x that we're looking for. Let's go ahead and set up that algebraic statement here. 3x plus 14 is equal to 50. Okay, let's subtract 14 from both sides. 3x is equal to 36. And then divide by the coefficient of 3. X equals 12. So there's our answer to question number 3. The value of x is 12. Now to find the value of y, it's a little bit more complicated, but the idea is still the same. And I can, as a teacher, I can already anticipate some people are going to have some problems with this one. But how do you find that segment right there? That's the big question that we're tackling for question number 4 here. But again, the idea is still the same. We're going to set up the proportion, right? And we're going to compare the smaller triangle, segment BE, by the way, of 4 to 5. So 4 is being compared to 5. And the segment from the smaller triangle containing the y would be this one, the 5.6, being compared to not just y, it's going to be 5.6 plus y. Oops, 5.6 plus y. And the reason is because the smaller side right here is 5.6, just like it's written. But then segment AD is going to be 5.6 plus y. So the segment all the way from this side to this side is basically 5.6 plus y, and this is what we're going to use right here. Okay, hopefully that made sense. But anyway, from right here we're going to go ahead and cross multiply these two. So 5.6 times 5 gives us 28, and that's going to be equal to 4 times that binomial term here, 5.6 plus y. Okay, and then if we distribute that 4, we should end up with 28 is equal to, what is that? 22.4 plus 4y. Okay, then we're going to subtract 22.4 from both sides. And then you should end up with, what is that? 5.6 is equal to 4y. And then divide by 4. And we end up with, what is that, 1.4. 1.4 is equal to y. Not 14, 1.4. Right, that decimal is kind of hard to see. 1.4 equals y.